Yeah, hello everyone, myself Maruti. Welcome you all to this math video session. In this video, I'm going to deal with the topic of linear pair of equations under two variables. Okay, so as usual, real life applications, deducting some unknown values, right? Banking sector, geometrical sector. Now I'm moving to the traveling point. Okay, so obviously when an object is traveling, we are having three things to be known, right? The speed of the object, the distance covered by the object, and the time in which it is traveling. These are the three general things when we are talking about anything which is moving, right? The speed of the object, the distance traveled by the object, and the time taken by the object to move. Okay. So now here in this question, as generally as it is linear pair of equation under two variables, we are talking about two concepts, two moving objects. So the two moving objects what we have taken is two cars, right? So now, when we are talking about two concepts and two cars, where they are starting, in which direction they are moving, right? How much time they travel, how much distance they travel, all those comes under, right? So let's go to the question now, right? Places A and B are 100 kilometers apart. So we are choosing 2 points for place A and place B, and the distance between the 2 points is 100 kilometers. Okay, on the highway. One car starts at A and the other car starts at B at the same time at a different speed. So just now I said you distance, speed and time. Right here, right, they said different speeds means two different speeds, right? Time, same time. They are traveling at the same time. Okay, and they are supposed to cover a distance of 100 kilometers. Now, okay, so two cars are moving. Now the point is in which direction they are moving, right? Are they moving towards each other, right? Are they moving away from each other? Or are they moving in the same direction, one at the back of the other? Is it cool? Are they moving in the same direction, right? Opposite direction? What are all? That's the question here is. Right, so A and B are 100 kilometers apart, you got it. On a highway, one car starts at A and another car starts at B at the same time at different speeds. Cool, we got it. If the cars travel in the same direction, if the cars are traveling in the same direction, right, one car is moving forward and the other car is at the back of them, right, moving in the same direction. Cool. Right, if they are moving in the same direction, they meet in 5 hours. This is a beautiful point what you are supposed to understand now. Right, if car A and B, if they are moving, of course, this one started at A and this one started at B. Okay, so this one started moving. What he said, they are moving in the same direction but different speeds, right? So we don't know the speeds. Let us assume the speed of one car as A and the speed of the other car as X and Y. Speed of first car, X kilometers per hour. Speed of second car, Y kilometers per hour. Okay, so they are moving in the same direction. Yes. If they move, for how many hours did they move? They moved for 5 hours. Okay, I got it. But what he is saying, after traveling 5 hours, they met with each other. They met at the same place. What does it mean? Do you think are they traveling the same speed? No. If they travel in the same speed, they never meet. Okay, right. If they are traveling the same speed, they never meet. But what he said, after 5 hours, when they are traveling in the same direction, they meet with each other. Got it? What does it mean? Means the first car, the car which is at the back, is moving with more speed than the car which is in front. Why? Because it traveled and met with that. If the speed of the one which is at the back, if it is more, then only it can meet. Of course, after a certain distance. But what he has given, the distance between the two cars is 100 kilometers. Means after 5 hours, whatever distance traveled by this car has to travel more than that. Means it has to travel the same distance what this car has moved, and it has to cover the gap between them. Suppose this car travels something like 400, then how much distance this car has to travel? The distance traveled by the car and also the gap between that is plus 100. Means it has to travel 500 kilometers, right? When this travels 400 kilometers, so that they meet at certain point after 5 hours. You got the meaning? You got the meaning? If this, suppose, let's go. If this car travels for something like in 5 hours, it is traveling something like 250 kilometers. Okay, in 5 hours, this car is traveling for 250 kilometers, right? What he said, after 5 hours, this car has to meet that. Means it has to travel 250 plus the 100 kilometers gap between that. Means this car has to travel 250 plus 100, that is 350 kilometers. So that after 5 hours, they meet with each other. Hope you are able to understand. Let us go that sum in terms of steps now. Alright, so let A and B are 2 kilometers, right? So let's go from here. Two cars, A and B. Okay, so what are the names of the cars? A and B. At two cars A and B places. Two cars are at A and B places. They are starting. First car is starting at A and second car is starting at B. Right. Distance between two cars. Right. What is the distance between two cars? It's nothing but, right, AB. The distance AB is equal to 100 kilometers. That's what he said. Okay, but we don't know the speed of that. Let's begin with the right. We are taking the first car, right? This is place A and this is place B. Point 1, right? So this is the distance between. Here the distance is 100 kilometers. Okay, now we are making the first car to start from here. This is first car and this is the second car. Okay, right, if it is moving in the same direction, let's imagine the first case as moving in the same direction. Okay, so which are the two places? Name of the first place is A and the second one is B. Right, distance between the two places is 100 kilometers. Now we need to talk regarding the three variants: the speed, right, the time and the distance. We are supposed to talk about all these three. Now let's talk about here what is traveling. Right. Find the speed of each car. He is asking us to find the speed of each car. Means we don't know the speed. So let's take it. Let the speed of first car. Let's the speed of first car equals x kilometers per hour. What is the speed of the first car? So we are talking about the first variable here, the speed, right? So speed of first car is x kilometers per hour. In the same way, speed of second car. How much we are taking? Y kilometers per hour. So we are done with the speed, time and distance of first, and speed, time and distance. We need to talk about all those three, right? So what is the speed of the first car? It's nothing but x kilometers per hour. And here we are talking about y kilometers per hour. This is the first case. Now, how much time they traveled? What is the point they say? Right. 5 hours. They traveled for 5 hours, right? So we are talking about the case 1. Here this is nothing but case 1. Right. What is the case? Right. They are traveling in the same direction. They are traveling in, right, let us take here. They are traveling in same direction. In same direction. This is the point we are talking. Right? They are traveling in same direction. We got it? So speed we were talking about. We are done. And for what is the time they are traveling? They are traveling for 5 hours. Right? Time of traveling. Time of traveling. Time of traveling for first car, first and second cars both is equal to 5 hours. That is what time of traveling, right? But first car is also traveling for 5 hours and second car is also traveling for 5 hours. We are cool, right? So I repeat, we are talking about two places, A and B, first car and the second car, and we are talking about right the direction. They are moving in the same direction. Okay, this is case 1, right? So, right, what he says, how many hours they traveled? 5. What are the variables? S, T and T. Now, we are talking about the distance traveled, right? He didn't give. He has given the total distance between the two cars as 100 kilometers, but he didn't give what is the distance traveled by the first car and what is the distance traveled by the second car. He didn't give it, but he has given only one point, that they are meeting after traveling 5 hours. So, to know regarding the distance, so what is the formula relating speed, distance and time? That's the formula. So, we know that always deal with the formula. We know that speed equals distance by time, right? This is the formula what we are having. Speed equals distance by time, that is S equals D by T, right? Now if you check it out, speed is known by us and time is known by us. What is the one which you are missing? It's nothing but the distance. So let's convert the formula in terms of the distance. So shall we say distance is equal to speed into time? Yes, distance. I am transposing this one. So to know the distance, always use the formula D is equal to S into T. Right? So this is the formula what we are knowing. Now by using this formula, let's go with the distance traveled by distance traveled, right, by first car, What is the distance traveled by the first car? I like to call it as D1, right? If you want S1, T1, D1, S2, T2, D2, you can call it as. So what is the distance traveled by first car? Is nothing but speed into time. Speed of first car times time traveled. Yeah, right. So what is the time traveling? So D1, what is the speed of the first car? Speed of the first car, we call it as X. Right, and what is the time of traveling? Both are traveling for 5 hours, right? 5 hours. So it's nothing but 5, which implies D1 is equal to 5x. What is the distance traveled by the first car? It's nothing but 5x. Cool. Now, what is the distance traveled by the second car? Right, D2. Straight away, what is the speed of the second car? Second car, what is the speed we are talking about? Y. Right, times what is the time of traveling? Here also, this is also traveling for 5, right, which equals 5y. So the distance traveled by the second car is nothing but 5y. Cool. Now the main logic lies here. So we are dealing with case 1, right? Yeah, hello guys, look at the first case what he has given the question. Case 1. After traveling 5 hours, both the cars meet. That is the point what he has given. I repeat the point. After traveling 5 hours, both the cars meet. Right. So if you assume the car A at so and so place and car B at so and so place, and as we already know, the distance between the two cars is nothing but 100 kilometers. According to the case, just now we have understood the distance traveled by the car A, we have already said in 5 hours it is traveling 5x kilometers. right? That is from here to here, this is the distance traveled. This is the distance traveled by the car in 5 hours. That is d1 is equal to number of hours into speed, that is 5 into x, 5x kilometers, and the distance traveled by the second car is nothing but 5 hours into speed, that is 5 into y. The distance traveled by the second car is nothing but 5y, right? So according to the situation, after traveling 5 hours, both the car A and both the car B, and they meet at a point somewhere at C. Right. What does it mean? What does it mean? Means as the speed of the car A is more, right, it traveled more distance. What is that more distance? Means it has covered up the distance between A and B. Earlier the gap between both of them is 100. What does it mean? It traveled 100 meters more than the distance traveled by the car B. Right, that is, if you can assume the distance traveled by the car B is nothing but d2 is equal to 5y, and the distance traveled by the car A is nothing but 5x. But this distance, that is distance traveled by the car A, is 100 kilometers more than the distance traveled. Why? Because it met at a point. What does the meaning it met? Means it traveled, means the first car traveled 100 kilometers, covered up the distance of 100 meters, and also traveled the distance traveled by the second car, and met at the point C after 5 hours. This is the cool point what you are supposed to remember, right? The distance traveled by the second car is only 5y. First car has met the car B after 5 hours, means it traveled the distance of this and also covered up the distance of 100 kilometers. That is distance d1, though it is 5x, this 5x is the combination of 100 and also 5y. That is what you are supposed to remember. So the distance traveled by the first car traveled 100 kilometers more than the second car. That is the point what you have to remember. So that is distance traveled by the first car equals distance traveled by the second car plus 100. Hope you are able to understand. Distance traveled by the second car is 5y, right? And it has covered up the distance of the gap between them as 100. That is distance traveled by the first car equals d2, distance traveled by the second car, plus 100. If you check out the calculations there, we can straight away go there. So distance traveled by the first car, we have given it as 5x, and distance traveled by the second car is nothing but 5y plus 100, the difference or the gap between both of them, right? If I transpose that 5y to the other side, it becomes minus 5y, and 5x minus 5y is equal to 100. This is the relation what we are getting. Means the difference of both the distances 100 is given up here, right? So if you take 5 common here, right, it is 5 into x minus y is equal to 100, and we can cancel 5 ones and 5 20s. That is x minus y equals 20. This is the equation 1 what we are getting. So hope you are able to understand. This is the case 1 what he has given. Right, so they are meeting at the point B, but the point C means car 1 has traveled 100 kilometers, means the distance traveled by car A and the car B, the difference between the distances equals, the difference between the distances is nothing but 100. Right, car A, distance traveled by car A minus distance traveled by car B is nothing but the gap between them. That is also one of the relation we can take. This is how we are framing the relation 1, that is x minus y equals 20. Let's come back to the second case. So in the first case, they are moving in the same direction, right? But in the second case, they are traveling in the opposite direction. First car and the second car. First car from point A and second car from point B. They are moving in the opposite direction. We have to note down that. So what he says, if they travel towards each other, they meet in 1 hour. That is what I'm checking car A and car B. The distance between them is 100 kilometers, right? They are moving towards each other, right? Means they are traveling in the opposite direction towards each other. You can say towards each other or in the opposite direction. Okay, now what is the speed? We already discussed the speed is x kilometers per hour. And here the speed of the second car is nothing but y kilometers per hour. This we have already discussed. Okay, now the time, he is saying they meet in 1 hour. The time of the first one is 1 hour and the time here is also 1 hour. They meet in 1 hour, means they travel for only 1 hour. Right, in the earlier example they traveled, both of them traveled for 5 hours. But here they traveled for only 1 hour. That's cool. But what is the distance traveled matters. Just now I said you, right, distance is equal to speed into time. Distance is equal to speed into time. That's the main point here, right? Before that, right, so the distance is equal to speed into time. So distance traveled by first car. What's the distance traveled by first car? D1 I like to take, right? What is the speed? X into time. How much is that? It's nothing but 1 hour. So 1 hour. So shall I say D1 is equal to 1x or simply x? Yes. In the same way, distance traveled by second car, I like to call it as D2. Right, D2, how much is that? What is the speed of the second car? Speed of the second car is y and the time traveled is 1. Therefore, 1 into y, simply 1 kilometer or x kilometer distance. Okay, but what is the relation? Logic what he has said. The logic what he said is they meet after 1 hour. They meet after 1 hour. Means, right, what is the meaning of meeting? Both of them together travel the total distance. They meet, what he said? They meet, logic. They meet after 1 hour. After 1 hour. So this is the logic what he has given. That means what? Right, that is they traveled the total 100 kilometers. Both of them travel together. They traveled the total 100 kilometers together. That is what we are going to learn. That is distance of first car distance plus second car distance, equals 100 kilometers. This is what they have traveled. Where they are meeting, at which point we are meeting, we are least bother. But they met. Met means both of them together completed the figure of 100 kilometers. They traveled the distance of 100 kilometers. Means, that is first car distance plus second car distance is equal to 100 kilometers. What is the distance traveled by the first car? Is nothing but x kilometers plus what is the distance traveled by the second car? Y kilometers is equal to 100. This is the equation what we got from the second equation. I like to repeat it. They are traveling in the opposite direction or towards each other. Fine. So traveling in the opposite direction. So distance is equal to speed into time. So we know the speed of the first car, x, speed of the second car, y kilometers. The time 1 hour, you can represent it there. The distance matter. What is the distance formula? Speed into time. Speed into time. X into 1, it's x. And here y into 1, it's nothing but y. Distance traveled of the first car is x and distance traveled by the second car is y. Means somewhere it has traveled x and this one somewhere it traveled y. But together they traveled 100 kilometers. This traveled for x kilometers, this traveled for y kilometers, and together they traveled 100 kilometers. They covered up. That is what he said. To x, right, this is what we got it. Now we are having the equation. Earlier we are having equation. This is equation 1. Solving equation 1 and 2. Right, 1 and 2. The first two equations, just now we got it. X minus y equals 20. And the second equation, x plus y equals 100. Okay, if you cancel this stuff, 2x is equal to 120, x is equal to 60 kilometers per hour. Right, what is x? The speed of the first car. Now, we need to know speed of the second car. Substituting substituting x is equal to 60 in equation any1. So I like to go with equation 2. What does equation 2 says? X plus y equals 100. If you plug in the 60 plus y equals 100, y is equal to 40 kilometers per hour. Right. So what is the first speed of the first car? 60 kilometers per hour. That's what we said. First car has to travel with much speed than the second car, so that it covers that 100 kilometer and meets the second car after 5 hours. That is in the case 1. Right. So see, here it is the first car speed. Right. What is first car speed? X, right. And the second car speed. Right, this is how we are supposed to check it out. But if you like to know, if you like to verify that one, it's a cool logic. So what is the speed of the first car? 60. How many hours it to travel? 5 hours. So 60 into 5, it's nothing but 300. Okay, now in 5 hours, what is that? If the time of traveling is 5 hours and speed is 40, right? 5 into 40, 200, right? So it's 200, right? And what is the difference between both of them? It's nothing but 100 kilometers, which is the gap in between them. Hope you are able to understand. This is the verification. How you do? It's a beautiful. In this channel, I have been placing both math and science videos.